Hi, this is Math Kimchi, and today we will learn about complementary counting. The idea of complementary counting is that sometimes, instead of trying to find the number of x's, we can find the total cases and subtract it by everything that is not x. And a similar problem would be to find the blue area, we can find the total area of the rectangle and subtract it by the triangle's area. An example of complementary counting would be to solve this question, which is how many integers in between 0 and 999 inclusive has an 8 as at least one of its digits. By inclusive, I mean 0 and 999 counts, but they don't really matter since none of them has an 8 in it anyways, and if it was exclusive, it won't change the answer we get. So the total number of integers between 0 and 999 is 10 choices for the hundredths digit times 10 choices for the tenths digit, and finally 10 choices for the ones digit. And if we multiply all that, we get 1,000. And what we don't want, or everything that does not have an 8, would be 9, because we are not counting 8 for the hundredths digit, and also 9 for the tenths digit, and 9 for the ones digit. If we multiply all that, we get 729 as what we do not want. For what we want, so something that has at least one 8, we just subtract 1,000 by 721, since the 1,000 is the total and what we don't want is 729. And if we subtract that, we get 271, which is higher than I thought. But if we were to solve this with some other method, for example, if we were to find all the cases with exactly 1/8 and then find all the cases with exactly 2/8 and then find all the cases with exactly 3/8 and then added them together, we would have the same answer, but it would have taken much longer than this. But in other cases, it might be faster to use some different method instead of complementary counting. Now that we have gone through a problem with complementary counting, I have 3 practice problems for you to try alone. So the first one is how many random integers between 0 and 999 inclusive has a 7 and or 8 as at least one of its digits. So this is similar to what we just did, but you will have to change the numbers a little bit. And the second question is, how many ways can I flip a coin 10 times and have at least one tail? The third question is, how many ways can I flip a coin 10 times and have at least one tail and at least one head? And thank you for watching. That's it for this video.